Algebra 2 Notes 3, 1, and 2, Solving Special Systems of Equations. So go ahead and do these warm-up problems and graph the system of equations. So go ahead and pause your video and then you can check it. Alright, if we graph the first one there, we end up seeing that they're the exact same equation. Okay, so if we get two lines, two systems of equations to be the exact same equation, we're going to say how many solutions are there. It's not all solutions, but there's a bunch of solutions. So we can say infinitely many solutions. Because anytime those two lines cross, there's a solution. Well, the two lines are crossing on all of these points. So an infinite number of points. It doesn't even have to be perfectly on the X and Y kind of dot plot. It can be anywhere on that line, and that line goes forever. Okay, for the second one, these lines, so we're thinking systems of equations. When will these lines cross? These lines will never cross because they're parallel. So how many solutions does it have? It has no solutions. All right, let's see what these would look like if we wanted to solve them algebraically. All right, so if we have example 1 here, solve the system, check by graphing. So we can solve it for y, move the x to the other side, y equals x minus 1. And then I'll go ahead and try this one by substitution. So if we have y now solve for itself, I'm going to fill that into the second equation. Negative x plus y equals 2. You could have done elimination pretty quickly too, so feel free to do that method if you'd rather. Okay, so we end up getting negative x plus x minus 1 equals 2. So if I simplify that, negative x plus x cancels the x. So we end up getting negative 1 equals 2. Does negative 1 equal 2? No, negative 1 does not equal 2, so it will be no solutions. Okay, so if you solve a system algebraically and you get all the variables to cancel out, but the two numbers do not equal, that's going to be that case where the lines were parallel. When will they cross? They will never cross. No solutions. Okay, you can go ahead and graph it quick. I'm going to pause the video. All right, so then we see the lines are parallel, which means they will never cross. No solutions. All right, why don't you guys try these last two? You can do elimination or substitution, whatever the equation lends itself to use. All right, so number 2, if I finish this up here, one thing I wanted to point out, don't forget if you have a negative 1 or a negative something out front, you need to distribute it to both items. On the assignment from yesterday, some of you guys forgot to do that. So make sure you distribute it so it should be a negative 2x and a negative 1. So then we can add like terms, 2x minus 2x is cancel, negative 1 plus 1, that will cancel as well. So if you get something like 0 equals 0, or 4 equals 4, or 1 equals 1, and it's a true statement as you are solving the system of equations, then you can say that this is infinitely many solutions. So infinitely many solutions. And number 3, as we go through that one, I did, this time I did an elimination. So I had to take my second row times 2. The first row I just had to move the 4y to the left. Once I add those up, I get 0 equals 18. Does 0 equal 18? No, 0 does not equal 18. This is going to be the no solutions. Okay, so you're going to get no solutions if your x's and y's cancel, but your two values are not equivalent, and you're going to get infinitely many solutions if your x's and y's cancel, but you get the same answer on both sides. 0 equals 0, or 3 equals 3, that sort of thing. Okay, all right. Your assignment is on GoFormative. So if you've not used GoFormative yet, there's a link for you to join Formative on Canvas. So if you just click on the assignment name, I think I couldn't put the whole name, it wouldn't fit. So it's just like maybe special systems or something. but you can click on that and that will help you get to the website. So when you are doing that, make sure you write out, when you're doing the GoFormative, write out the answer. I think I put on there what to write, but just like these are either no solutions, infinitely many, or you could actually get a solution. Okay? All right. So let me know if you guys have any questions. I'll be in the Zoom meeting today. So come on in. Talk to you later.